All right, welcome everybody. Today is Wednesday, September 9th. This is CIS 175. Good evening. So I initially had planned on doing chapter 1. Whoa! What's up, May? They have been. Make sure you refresh the page. I only did it like right before class. Originally, I had planned on teaching chapter 1 in one lecture, and then I reread chapter 1, and I was like, oh, we've got considerable amounts of vocabulary and subject matter here. So I sent out a mail to the class mailing list and said that I'm splitting that up between 2 weeks. So hopefully, well, I know that you all had already read all of chapter 1 before I sent out that mail, right? In any case, we're going to be doing the first part today, and then next week we're going to be doing the second part. First, though, before we do that, everybody, if you're here, please sign in to CCC Confer. I see pretty much monitors up consistently. Anyone having trouble? CCC Confer basically working for us all. Groovy. Next, if you would just go to my website, hit the roll call link, and fill in your first name, last name, and what course you're in. Now, do that or do something that at least I'll know it's you. This is incredibly important today, and of course last week's too. Guys. This is incredibly important today because at the end of this week I have to do census, and that means if you haven't shown up to class at all, I have to throw you off the class roster. So the way I know that you've shown up to class is that you've done this roll call. And so it's extra important that you do that today. Okay, now when you have gotten to my website and you've gone to the roll call and you've done it, I would appreciate it if you could let me know that it's done by just putting a check yes by your name. So you got a question?
I was having issues trying to get the actual thing for the file so I can actually get into the class thing through Collaborate.
Mm-hmm. You can always skip running the installer. That basically works.
No, it was like saying it was basically saying like this session was over like May 24th, 2015.
Curious. Friggin'. Okay, so let's see what we got here. How about Roberto? Are you here or are you in the ether? Roberto? You Roberto? Nope. Are you signed in? Yeah. Or, why isn't there a check by your name? Check mark. Oh, maybe I'm talking to the wrong person. Who's Snoochie Boochies? Okay, here we go. Snoochie Boochies, we're good. Roberto is obviously getting a beer, making a sandwich, hanging out in his undies. Joseph is giving me X's everywhere. All right, well. Okay. Okay, you're Joseph. Sorry.
Yes. All right. Just to let you know, I clocked in the roll call for camera. Okay. So it was under something else. You were saying something about the roll call. I was just saying that I put my name as camera.
Okay. Okay. That's good enough. Hi, Roberto. It's nice to see you. I do the making a sandwich joke pretty much every week. You'll get really sick of it. Thank you. All right. So, Efren, when you get signed in, just go ahead and give me the check, but we're going to move on. All right. Thank you for taking roll, everyone. Like I said, it's especially important this week. Okay, so today, if you could finish Lab 0 by the end of today and turn it in on Blackboard. Lab 0 is 2 questions. Who's in your group and what do you want to get out of this class? All right, so when we go to break after I stop talking, anybody who is lacking a group at this point or has a group of two people, I'd like it if you come up to me. What I'm going to try and do is pool as many of you as possible so that we have groups enough to have a real discussion. So that answers question 1. Question 2. You don't even have to study for question 2. So everybody, please try and get lab 0 in today. Lab 1 is also going to be due at midnight tonight. It involves the lab that we're going to do on NetLab, and it's really just a couple of questions about how you found your NetLab experience. Really, it's asking you questions about NetLab. You just want to make sure you get at least some of the steps done today. This is going to be the first day we're really going to try to all get into NetLab, so we're going to see how it goes. Yeah?
I thought you said NetLab was due next week.
No, the project is due next week.
Oh.
And it's important for all of you guys to remember that next week, one representative of your group is going to have to stand here and present what you guys discussed in your project. And you're also going to have to tell me that your group met. Now, if all of your group is online, then one person is going to have to put the microphone and camera on themselves and do that. So be ready. Make sure it's going to work. CCC Confer has a test to make sure my camera works link. It might be a good idea to do that. Now, that said, I'm anticipating possibly a little chaos next week, so we're going to just try and make it work, okay? By the way, like I said last week, video conferencing is really a key technology for any technology worker on the planet today. There's a lot of things that really suck about it, and we're all going to kind of learn those things, like the person with the barking dog, etc. Right? So get used to it. You guys, for those of you who are gonna do this on camera, you're gonna learn why everybody loves you if you mute your line. All right. So any questions before I begin? Any questions about last week? Any questions about project, homework?
So just to clarify, we're doing lab 1 tonight, which is due tonight.
Yes.
And project 1 is due next week.
Yes.
Right.
All right. Well, all right then. How to think like a security wonk and use your words, really use their words too. Subject for this lecture. By the way, if anybody online has a question, just type it in or ding us. I'm going to try and do this sort of part as interactively as possible. What is security? Well, security is protection. Information security is protection of the critical characteristics of information. You might be asking yourself what those are. Well, you're not going to be asking yourself that for very long. Information security requires not only communication and network security, but physical security as well. So what is communication and network security? Well, if I'm going to pick up the phone and call you, not only if that call is going to be secure, not only does it have to be that no one is tapping the line, but it also has to be that no one's sitting next to me to listen to what I'm saying. Right? Communication is the art of protecting data as it travels from one place to another. In order for data to be useful, most of the time it has to pick itself up from where it is and go somewhere else where it gets used. Network security is a subset of communication security. So communication security would include a telephone call, and network security really pertains only to data. And then, of course, physical security. The importance of physical security really can't be underestimated. When you have access to touching the machine, you can do a whole lot of things to it. For example, if you were in a data center and you really wanted to get access to, say, a particular router, maybe you just wanted to destroy it without bashing it with a hammer. you know, you could plug into the serial port on the router and you could try passwords and passwords and passwords. But you know, you can also reboot the router and reset the password and clear out its configuration, right? You know, how about this? Have you ever been to an Airbnb or like a vacation rental, and they're like, you know, the wireless is not for guest use? And you're like, the hell it isn't. So you haven't told me your password, and I don't even need to guess it because I have a paperclip. I'm just going to reset your stupid router, and the password's going to be password, and now I have access to your network. Thank you. Have a nice day. Right?
Some men wasn't likely to get kicked out of the resort.
You know, they might be a little mad at you for that kind of stuff. Well, that's the point. Is physical access can defeat almost any security measure, even the best designed security measure. Even if their password was 68 characters long, it still can't beat a paperclip. Right? If you can touch it, you can reset it. Have a nice day. Yeah.
But isn't that considered like illegal to reset someone's or phone?
I don't know if that's illegal. It's definitely rude.
Yeah.
It could be illegal, and it's definitely. I would not support doing that. You know, like.
It's illegal if you reset it and then you go into the settings and change your settings to you. So like if somebody else's, if you're on somebody else's.
No, I mean
changing those settings are basically hijacking your network so they can't unlock them out.
I think. Well, I wouldn't be surprised if even resetting is illegal.
You totally can.
Anyway. So you might ask, what are the characteristics of information that make it so valuable? There happen to be 7 of them. I was like, I had to count on my fingers to count. Like 5 plus 2, 7. Availability, accuracy, authenticity, confidentiality, integrity, utility, and possession. Settle down. Generally speaking, if information has all of these, it is of value to someone. Lacking one of these either totally destroys its value or makes it so that its value is lessened. Like, for example, my social security number is a number that should be in my possession, right? It better be in my head if I'm going to go take out a bank loan. If it's not, that information is not valuable to me because I don't have it. I can't use it. A lot of information that is, another example, given the social security number, is, well, that information is of value, most value to me if it's private, if it's confidential. If you know my social security number and my birthday, then you can open a bank account in my name, right? So part of what makes information valuable is that in some ways it stays secret, that you control it, and that you know it has not been corrupt or altered. You may also notice that 3 of these are bigger than the other ones, than the other 4 of them. Now, why is that? Well, 3 of these have existed since there was a thing as computer or information security. And they tacked the rest on because they started to realize, oh, we need a little bit more than just the big 3. So what's the big 3? Well, the big 3 is the CIA. Not the Central Intelligence Agency, but confidentiality, integrity, and availability. They are the most recognized characteristics, fundamental characteristics of information. And if you this book, like I said, is really trying to expand the art, But if you look at everything that's been written over the decades, you are going to see CIA, 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 CIA. These are the big three. So what are they? Well, information is confidential if it cannot be used by unauthorized people, or really, since we're talking about computers, programs. So cryptography and access controls, like setting file permissions in Windows or Linux, are technologies that are used to promote confidentiality. In other words, when you want to keep information secret, you might encrypt it. That's a technology that promotes confidentiality. So what kind of information would you want to keep confidential that's yours, that you say had in computer form? Ooh. If you have your social security number in a spreadsheet, best to keep it confidential. Yes.
Financial documents.
Right. You know, we all receive, so I don't actually get any paper bills anymore, right? All of my bills come in email, which is great. But that information has to be kept confidential, right? If you could see my PG&E bill or my water bill, I don't know what you could do, but using that account number, you might be able to go and screw around with me at least. In some places, in order to get a loan or something like that, they ask you for 2 months of your utility bills, right? If somebody could produce 2 months of your utility bills, they might be able to impersonate you. So that's why you keep some of your information confidential. My mother-in-law, her ex-boyfriend kept all of his passwords for every website in a spreadsheet, which is not an unreasonable thing to do, considering you really should have a different password for a lot of things. But as long as you can keep that information confidential, then it's not bad. It was on his own disk. Now, I was like, it was the first time I met the guy, and I was like, he's really opening up his passwords file right in front of me. I'm going to learn something about this guy now. And they were all variations of the make and model of his car, which was like a Camry. And I was like, you sir are really born to be mild. I can tell that. I was worried that you were an axe murderer, and now I'm not.
Probably recommend like password protecting that spreadsheet, just
right.
And have it on like your secret jump drive that you don't tell anybody about.
Or just turn off your computer when you're not using it. Okay, integrity. So we kind of know, people talk about integrity in the form of politicians, which is kind of like talking about freshness in the form of frozen food. But integrity as it relates to information is, information has integrity if it is whole, it's complete, and it's uncorrupted. So if you think about this lecture, if you're watching the recording and it cuts off halfway, it doesn't have much integrity. If it's edited down so that it seems like I'm selling fetuses online, it's not really integrity either. Right? And if the video and the audio is jumbled, then that's not integrity either. Right? So technologies like hashes and checksums are used to validate the integrity of information. So, and use your words. Okay, so somebody type into the chat window. Who can think of a use of a checksum? In the chat window. Where have you seen checksums used before?
A hash?
Or a hash. Passwords. But they're not really designed to protect the integrity of passwords. Yeah, Paul. Modem connections, packets.
Points?
Yeah. So at the end of every Ethernet frame, there is the FCS, the frame check sequence. right? That's a checksum. What does it do? When you get the packet, you can calculate the checksum yourself, and then you look at the checksum that came over the wire, and if they matched, then the packet was unaltered. The packet has integrity. It was whole, complete, and uncorrupted. And that's important. Now, availability, the last of our big three. Information is available if it is able to be used by authorized people and programs. In other words, Google is available if I can do a Google search. My presentation is available to me once I log in, and if it 404s because there's no presentation, then it's not available. Or if I forget to share it with you guys, or I forget, and I put the link on the site, right? You click, it says access denied, it is not available to you. I mean, availability is a pretty straightforward concept. It's having your data when you want it. And that's important because if you can't have it when you want it or you need it, it loses its value. Right? What's the value of this presentation if I show up to 175 and I'm like, sorry, Google ate my presentation. Right? I'm out. I wouldn't get docked pay, hopefully. But, it is still valuable to me. I'd lose face. You guys would think I was an idiot. Right? Reliable systems make data available. So what's an example of a way to make a system reliable? Right? Think about a disk. You've got one disk in your computer. Right? What if you put two disks in your computer and you have the same data copied on each one? Does anybody know what that?
RAID?
Yeah, it can be called RAID. Sometimes it's called varying. There's lots of different names for that. But that means that if one disk dies on you, the data is still on the other disk and therefore available to you. Right? The system is more reliable and therefore more available, and that preserves the value of the data. Yeah.
Is that where backups come in?
Backups are another way to make data available. If your data gets washed away in a flood, then it is no longer available. If that was your only copy, it will never be available again. If you had a backup, then it may take a little time, but you're going to get it. So, who can tell me this and type it? I want to give people in the chat a chance too. What is the difference between confidentiality and availability? They seem maybe very, very similar, right?
Nothing.
Oh, problems I can't type it down.
Now you're just froze and I have to redo it.
Availability. Lost. Go down.
Pretty good sums it up right there.
That is exactly it. Confidentiality is in itself a negative, right? And availability is a positive. So let's think about this example. I think of my deepest, darkest secret, right? The one thing that if the world knew about me, I'd be ruined forever, right? Like that day that I once threw a cat in the trash. Just kidding. That actually happened to somebody, except it was on video, right? So I write that down, right? I write that down in a text file. I encrypt it 3 times with 3 different encryption keys, and I throw away all 3 keys, right? Is that data available to me any longer?
No.
No. It's lost. I can't get the key, right? Is it confidential? Yeah. No one else is going to get it, right? And so that's the difference. Availability is a positive and confidentiality is a negative. What can authorized people do? What can unauthorized people not do? Okay, moving on. Accuracy. probably seems pretty redundant to anybody who speaks English, but information is accurate if it's correct and error-free. Inaccurate data is usually the fault of people. And no technology really can make people not make mistakes, unfortunately. But accuracy is the property that the information you're presented with is correct. So if integrity is unaltered and accuracy is correct, what's the difference between accuracy and integrity?
Want to answer that?
Do it. Yeah.
So, I mean, even if you go to Google, take Wikipedia, my understanding that's like anybody can do Wikipedia, and that's not always accurate. It's just what people. So, I mean, what would you recommend a good source of accurate information?
Well, Carlos, I think Wikipedia is generally pretty good, but Carlos brings up an excellent point. If you go to Wikipedia and you pull up an article on something that is somewhat controversial, say, right, where vandals come and screw up the page, like, people go and say, the Earth is 6,000 years old or something, right? Then, if the Wikipedia article actually says that, and that is the information in Wikipedia's database, when you load that page and the page is presented to you, if you're seeing what's actually in the database, then that data has integrity. That doesn't make it right. It's not accurate. So it's not as valuable. Right? Just like if Andrew, say, gets a question wrong on the midterm.
What?
As long as I see what he answered, then it's got integrity, right? If his answer wasn't changed by Blackboard on its way to me, it has integrity. But if it's wrong, it's wrong. It's the human error element that makes things inaccurate, generally speaking. Because if a computer screwed up to make it inaccurate, that's a problem with integrity. Right. Exactly. Faulty, faulty, people fat-fingering things like, the Mars lander that crashed because of, metric and standard, stuff like that. Okay. Authenticity. And this is going to be kind of a theme in the class a little bit. Information is authentic if it's genuine and you can verify who it comes from. You can verify its source. So when information is authentic, you know positively who it came from. And one of the themes in this class is, how do you know who to trust on the internet? The answer is, well, you just kind of do, but maybe you shouldn't. Asymmetric encryption and digital certificates are technologies that are used for authenticity. So one of the big differences between going to Google and going to opus.cis.cabrillo.edu is that when you go to Google, you get that HTTPS green icon in your browser that says, this site's kosher. And when you go to any of our websites, you get a beware.
That's true.
Why? Because our certificates are bogus. Our certificates are self-signed. To have a real certificate, you have to pay, right? And that's just, too deep down on our to-do list to go do. And what that means for the browser is that the browser knows that our certificate is bogus, and it says, you know what? I cannot independently verify that CIS.cabrillo.edu is where you are, is where this information came from. I don't know that for sure, and I'm going to tell you that. I'm going to tell you that in the form of an error message and then crossing out the HTTPS, right? Not secure. And that's good. It's good that browsers do that. Chrome is a little heavy-handed, but That's good, right? So how do you know someone's driver's license is real? Like if I produce my driver's license, how do you know it's the real deal?
There's ways to tell. Can you get food delivered?
They have to see the quality and see if it's up with the quality of the other driver's license.
Yeah, you can kind of like, if somebody just printed it on a color printer, it's going to be pretty obvious. Right?
Well, most people, if you're going to try to replicate a driver's license, they're not that stupid. They'll definitely try to make it look authentic.
They have so I got a new driver's license, and they have like Braille on it, right? They've got bumps, and they've got a hologram, and they've got a magnetic stripe. All these things, yeah, the hologram. And if you're a cop, you swipe that magnetic stripe, and then it goes and calls home and says, "Oh, you're looking at John J. Hacker, shoot on sight," right? You have a way that the authenticity of the driver's license is proofed by the physical features of it, the fact that it's got these things that are really hard for regular people to do. We can do a better job on the internet of providing or of verifying the authenticity of information, and certificates are a way of doing that. Okay, utility. Well, information is useful when it's useful. I tried to think of a pithy sentence for this, and I just, okay, if it's useful, it's useful. Useful information has value, and if it has value, there's value in protecting it. Right? That said, it's hard to really know what information is valuable. One hacker's trash is another hacker's treasure. Right? So let's think about this Windows machine here. Or actually, who's got their laptop with them? You got your laptop with them. What information is valuable on there? And what percentage of the total information on your laptop do you think is valuable? So somebody tell me, what's the least valuable thing? Put that in the chat window. What's not valuable on the laptop? The desktop picture. Yeah, Internet Explorer. Gabriel. Actually, yeah, that is absolutely true. Why? Because you can just go download it again. In fact, you can't even help it. It's just there with Windows, right? So okay, so I have on my laptop, which I didn't bring today, I have whole disk encryption, right? It won't even boot up unless you press the password. Press the password, type the password. My one character password. Password 5. Now you know. Yeah. Yeah, that's right. You couldn't get another browser. So I use whole disk encryption. And that means that I'm protecting my Linux operating system as strongly as I'm protecting all of my stored credit card information in Chrome. Right? And protecting it as well as I'm protecting the downloaded grades and rosters from past classes. Is that really necessary? Well, it's kind of like disk encryption. It's sort of like easier if you go all the way than if you like do pick and a poke kind of encryption. But I'm protecting a bunch of stuff that's not that valuable to hackers, because anybody can get Linux. It's not even valuable if I lose it, because I can just re-download it.
Backed up on the hard drives.
Well, I don't back up. I don't back up any of the system partitions. Because why? If my computer really died, I'd be like, well, it looks like I'm upgrading Linux today. Good thing my data is backed up, like the stuff I care about. Right? So knowing what information is useful should inform you about what steps you take to protect it. And then last, of the properties of information. You possess information when you possess the medium on which it's stored. So what do I mean by medium? Well, the hard disk is a medium. My phone has stored data in the flash memory, and right now, clutching it with two fists, I have total domination and control of this phone, unless somebody's hacking into it using the internet. And that means that I possess it. Data that's located on your home computer and nowhere else is data that you possess. And that's important, because your most valuable data you may want to possess. Now, losing possession of your data does not necessarily decrease its value or decrease any of the other attributes if, for example, you had it encrypted, like the data on my phone. Right? Somebody may be able to possess that data but not read it. However, like I said, the ultimate form of control is possessing it. So anybody want to, and again, let's hit the chat window. Why do we think Hillary Clinton had her own email server?
What, she did?
Oh, where have you been?
Not paying attention to the news.
By the way, if you want to learn how to make your own email server, that is like week 6 of CIS 192. Like, by the way, that story broke while I was teaching 192 last year, and I was like, oh, who would have their own email server? By the way, all of you by the end of this class. I mean, it's not really that extraordinary. Like, an email server is not like terribly high technology, but ultimately you got to think that whatever was going through her mind when she did that, the notion of possessing her emails had value, right? That's the risk you take. I am going to possess my emails, and therefore, ultimately, when the Republican-controlled Congress subpoenas it and says, look, she's a bitch because she balled out Chelsea's caterer for the wedding, right? She's going to be like, nope, nope, can't have that email, it's mine, right? Turns out, avoiding Republican witch hunt does not seem possible when you're Hillary Clinton. Or really, maybe she just made it worse, like it's the biggest face palm in like politics of this minute. But that's the, I mean, I don't really talk to Hillary much, or in fact ever. I shook Bill Clinton's hand once. Yeah, at CSUMB, he gave like the inaugural speech of CSUMB, and I got tickets. Lucky. I was like a freshman in college, I think, or sophomore in college. But you got to think that what's going through the mind of somebody with their own email server, no matter, is possession of your information, is control of it, right? If you're like, well, it's not illegal for me to delete personal information, of course I get to decide what's personal. Why? Because I'm possessing it, the only copy of it. Thank you, have a nice day. Okay, so circling back, security is protection. It's protection of the critical characteristics of information. What are those critical characteristics? Well, you now all know. Of course, you knew from reading the book, right? So if we're going to build ourselves a secure house, how are we going to build it? Well, it's got to be founded on the critical properties of information, of which I have abbreviated CIA. Confidentiality, integrity, and availability. And its pillars are computer security, data, and network security. That's what's going to hold the roof up. If you're going to have a secure environment, you need to have not only policies so that the people that work at your company understand what their responsibilities are, but you need to have management that's on board with those policies. And then you're going to hit the space key and nothing's going to happen. And once you have all of those things, you can put the roof on. You have information security, where your assets, your information is protected, and you have the ability to sanely govern the computer systems. Yeah. Animations. You have the ability to sanely govern the process and the systems in your company. Now we're going to talk about policy and management and some of that stuff in future weeks. Those are chapters ahead. But I thought the house picture was cool, so I built a house. Good job. Only 57 slides to go. So, there's a little more vocabulary that we need to have in order to understand some of the things that the book and the DBIR and some of the articles. So how many of you, did any of you guys read the Ars Technica article I sent to the mail list?
I forgot about it. I meant to read it.
It's basically how to make, it's how to make $15,000 in 1 hour of work. I would have put that as the title, but I thought maybe some of you might try it. Yeah. I'll tell you about it later. Yeah, I know. I should have made a more eye-popping title. Actually, I thought maybe if I did that, it would have been, you would have thought it was spam.
Well, we would have seen where it came from. So.
And you would have known it was spam. Okay. So, the terms that we have to, the key terms for understanding, for being able to dissect some of these problems that we're going to discuss are access, asset, attack, control, exploit, exposure, loss, security profile, risk, subjects, objects, threat, threat agent, and vulnerability.
It's a lot of words.
That's a lot of words. I was kind of like, I was not so stoked. I was like, wow, this, and it's just like, here's the list. So I tried to condense these into fewer slides by using them in a sentence. An asset is a thing of value that you protect. Assets can be physical, like a computer, which you don't want people to steal, or they can be information, which you would like to keep confidential. But you protect them from attacks by implementing controls, countermeasures, or safeguards. So let's talk about assets in terms of information. I'm going to use my laptop again. If somebody stole my laptop, I would be angry. And what they would have was whatever value they could derive from selling my laptop. What they would not have is my information like the credit card numbers that are punched into my browser. And that's because my laptop's encrypted, which is a control or a countermeasure or a safeguard. If you fail to implement a control or a countermeasure or safeguard, you experience a loss. A loss is a loss of one of the key attributes of information. It could be a loss of money. It could be a loss of your reputation or your standing in the community. It could be the loss of sleep or the loss of hair. That, unfortunately, is just going to happen no matter what. To me, anyway. Questions? Like I said, I'm cramming as many words on it and it slides as I can. Fairly clear?
That's 6. Good job.
More Tai Chi. Attacks. So let's talk about attacks. We saw attacks in the last slide, but you need to know more about attacks. Attacks can be intentional, unintentional, passive, active, direct, or indirect. That's a lot of different types of attacks. Every attack is going to be 3 of those, basically. So what are those? Intentional or unintentional? Sorry, dude. I spilled coffee on your computer. Unintentional. How about the cheapskates at work won't give me a new laptop, so I threw it off the top of the building?
That sounds bad.
Wasn't that dramatized? Didn't that happen in like a show?
There was a commercial.
Oh, it was a commercial.
It's like, hey, if boss doesn't want to give you a new laptop because everybody thinks your old one is fine, then go on ahead and spill coffee through every single small mistake, like spill coffee and throw it in the ditch. Say, hey boss, my computer is broken. Can you give me a new one?
Right. So throwing it off the building is intentional. Right? So in this case, in these two scenarios, what's the asset? Type it into the chat. What's the asset here? Between the spilled coffee and thrown off the building. Yeah. Anything else? Could there be anything else? Yeah. There could be data on the laptop. Wait, the coffee is... What? I gotta throw another cup now, or pot now? Duh. Right? Right. If you didn't back up the data on your laptop before you threw it off the building, then you lost the data too, like a numbskull, which would be really dumb for an intentional attack. The coffee, you might just have lost the data because you didn't really intend.
I guess somebody's going to be doing overtime again.
Right.
To try to redo all the work you do.
Yeah, that's going to be an expensive data recovery. For those kinds of data recoveries, they have to pull the hard disk apart and clean off the platters and image them with a special microscope. It's a pain.
Really?
Yeah.
Wow. That's how data recovery works. What's the reason why it's so expensive? They have to also take it in like a complete dust-free environment because of the
Passive or active? You left your Ashley Madison profile on your screen and you went to lunch. Now I know you cheat on your wife or your husband.
Oh, snap.
Right? Yeah. So for those of you who don't know, Ashley Madison was, and I really mean there's just absolutely no way they're going to operate for even another minute. Ashley Madison was a website where married people were supposed to sign up so that they could hook up with each other. Right? So it was a site for married people to have discreet affairs. Some hacker, somebody decided that they were going to go, download their entire client database and did, and exposed it. Primarily on the deep web, I guess, but I've heard that you can BitTorrent their database. And so, how about this? I BitTorrented the Ashley Madison database, and now I know you're a cheater, and I'm going to tell your spouse.
Oh,
right?
Or your spouse.
Active or passive? Active? This one, active or passive? Active. The one on my left, my left, you're right. If I actually go to the internet and download the database, I'm doing something. If I walk by your cubicle and your personal information jumps into my eyeballs, like your Ashley Madison profile, that is an attack, but it's a passive one. Right? I did not seek out that information. It just fell in my lap. Right? Another kind of passive attack is you put a bunch of private information on a flash key and you leave it in the break room. You would be shocked how often that happens. How about this? You print out a bunch of stuff and you leave it on the printer because right when you're about to get up and go to the printer, somebody's like, oh, hey, Bob, I got some questions, and then you get so distracted you forget to go to the printer. Happens all the time. Yeah. Right? And if somebody is like going to the printer because they happen to, and they happen to like work near the CEO, like my office was close to the CEO's office for a while, you go to the printer and you're like, bankruptcy? Right? So all your options, that's a passive attack, and that is an attack. I actually went to the bathroom once in my old company, and the CEO was throwing up in the sink. I sold a lot of shares that day. Looked like tuna fish.
Okay, really descriptive, man.
So, what countermeasure could have prevented this loss, the passive loss? Put that into the chat.
Wait, say it again?
What countermeasure could have prevented the passive loss when you left your Ashley Madison profile? Yeah. Window key plus L. Gabriel, lock the screen, log out, turn off. You know, how about don't surf Ashley Madison at work? But then again, I guess you really shouldn't surf it at home either. You're in a bind. Do it on your phone.
Don't use it.
You know, the best thing about teaching computer security is that the newspapers just provide you with the best stuff to talk about every day.
Really?
You want to know what the real scandal in Ashley Madison was? It was only 1% women, and a big fraction of those, when they listed out what the IP address of the last login was from, it was localhost. So a large fraction of the women were just made up women that were just like, what do you call it? There's a word for this. Like they were Ashley Madison employees.
I'll bet you anything they were storing some of their users. Like
yeah. So and that's, I mean, it's, you know, like they charged them monthly. Anyway,
Hey,
Ashley Madison, a site for people who haven't heard of Tinder. Go ahead.
Are these some examples of physical, or at least on the last two slides, are these examples of physical communication and network, or just physical things?
These are the, I mean, they could be any. I just picked attacks at random. You know, I just popping in there. What I wanted to illustrate was the difference between like passive and active. Or in the next slide, yeah, use someone else's device. Direct or indirect? Speaking of using someone else's device, I sent an email blackmailing the CEO who was registered with Ashley Madison. Direct or indirect?
Correct.
Yeah, I'm the attacker and the CEO is my victim. I sent an email blackmailing the CEO, why did it do that? Who is registered with Ashley Madison from your phone or your computer.
Indirect.
Exactly. I used you. So I attacked you for the purpose of attacking someone else. That's an indirect attack when you're talking about the person whose computer was used. Or sorry, when you're talking about the ultimate victim. So the CEO is the victim of an indirect attack because I went through somewhere else. Is blackmail an attack?
Yes. Straight up.
What are the key attributes of information that the blackmailer needs to have blackmail be successful?
Information.
No, put it in the chat. What does the blackmailer need for his or her blackmail to be successful? Access. Paul. Confidentiality. If the CEO goes to his wife and is like, I'm sorry, honey, I was registered, right? If the information that was secret between you and your victim stops being secret, then you as the attacker lose the value of that information as well, right?
Yeah.
Confidentiality. It matters in this case both to the attacker and the victim. All right. Exposure is when a vulnerability is known to a threat agent. So, there is a defect in this copy of Windows that will let you take complete control of it. I don't happen to know what it is, so it's not an exposure. If somebody does know what it is, then it is an exposure. There's an attack that will let you take over virtually any operating system. Now what that attack is may not be known, but you can bet people are looking for stuff like that. Those are often called zero-day exploits. Zero-day exploits. So what's an exploit? An exploit is when a threat agent exploits a vulnerability to do an attack. So exploit, I only used it in one sense. If you use it, I used it as a verb. It can also be used as a noun, which is what I said before. So a zero-day exploit is a procedure for performing exploitation, right? And what that is taking over a vulnerability or using a vulnerability for the purpose of making an attack.
Or, well, not always an attack. Like, for example, you use vulnerabilities to, gain root access to certain things like this.
So the comment is, well, it doesn't have to be an attack, right? You gain root access to your phone through vulnerabilities. Well, that is an attack, because that deprives the person who made your phone of the rights that they're trying to protect by not having you be root on it. Yeah. I mean, whether or not you feel they have those rights is maybe a little bit of a gray area, but they feel that they do, and that's why they try and keep you from being root on your phone. So again, a vulnerability is anything that you could use to break into something, but it's only exposure when an attacker knows about it. And that's kind of it's a subtle but important difference. Right? You know that there are vulnerabilities in virtually any computer system with any complexity, but you're only exposed once other people learn about them. Really, you hope that when they learn about them, you learn about them too, and then you can limit your exposure or by upgrading your operating system or fixing whatever security vulnerability or flaw. Yeah?
So was Heartbleed the zero-day? The SSH vulnerability from a few years ago?
So the question is did Heartbleed count as a zero-day? When it got published, it stops being a zero-day.
But I mean, were people actually exploiting it before it became?
The question, yeah. So the question is, was it being exploited out in the wild before researchers published it? No one really knows.
That's kind of scary.
It sucks. Heartbleed was a famous problem with SSL. Well, SSH uses SSL.
Oh yeah, sorry. Yeah.
So any website that had HTTPS that was based on the very popular OpenSSL package could be tricked into leaking out little pieces of information about itself. It'd be kind of like I'm sitting here and I'm eating my lunch, and every time you say to me, like, Mike, I just say what word I was just thinking. So you're like, Mike, and I'm like, sandwich. Mike, and I'm like, sex. Mike. No, I didn't mean to say that. What? You know, Mike, I'm going to blurt out my password.
Mike, you guys are right.
God, why did I say that? I was like, you could tell, I was like, make it clean, make it clean, make it... Anyway, sorry. But that's what Heartbleed did. If there was a piece, Heartbleed let hackers go and see a little piece of the computer's memory. They didn't have control over what piece that was, but whatever it was, it just came popping out. So what could pop out? Passwords. What could pop out? Program code. What could pop out? God knows what. Anything the computer was doing. You know, researchers... The reason it was called Heartbleed is because it took advantage of the heartbeat function of SSL. SSL has a function called heartbeat, which you have to kind of ping it every once in a while. So you could use that function to make it spill its guts to you.
One good time.
And you know, security researchers, if you're going to make an impact, you give your work a name like Heartbleed. Shell shock! You will die! Okay. Threats and threat agents. So you see that, like, what's the difference? Threat and threat agent is on there. Threat agent is kind of a mouthful. So a threat is like a classification or a category of things. And a threat agent is one particular instance of that category.
Threat or threat agent?
Yeah.
Threat agent.
Threat.
Threat? Threat agent, that's the person who sews your socks.
Yes, it is. Or it's the thread you like to read on.
Mm-hmm. Yeah. Proofreading, no. That, and by the way, that, yeah, the accuracy of my presentation is in serious question. The integrity seems fine, except for the CEO splitting. So I guess we got integrity. Okay. So threat. Computer viruses are threats. The Stuxnet virus is a threat agent. It is one particular threat. Natural disasters. They're a big threat to data security because they tend to delete things really fast. What's one threat agent? Superstorm Sandy. And I have a great picture of a data center underwater. Rapid delete.
Dropping your laptop.
Michael Jordan, threat or threat agent? Yeah. Threat agent. There you go. Clumsiness. Threat. Dropping your laptop, threat agent. Right? A particular instance of clumsiness. Oops. Yeah. So remember that. A threat, when you talk about a threat, you're talking about a broad category of things. And we're going to talk about some of the categories of threats later. Okay. Now to the words I had to throw in this slide because these were the ones that were left. You have access to read your grades on Blackboard. Access. I have access to read and write them. That's how the access control system works. Blackboard is an asset, then you and I are the subjects, and the grade is an object. Access control is the process of specifying the access that a subject has to an object. So for example, if you've ever set file permissions or share permissions in Windows you say who is allowed to read, who is allowed to write, who is allowed to execute, modify, full control. Right? You can go into Windows and you can set those permissions on a file-by-file basis. That's setting the access. When you do that, Windows asks you who the subject is, or in Windows speak that is, it just was in my brain, now it's out. And then the object is the file you're setting it on. What is that? I'll think of that in a second.
Group policy?
No. Looking at all the people who are in 194 and 195. Security principle. Security principle. That's it. The subject is the security principle in Windows speak. The subject is the who and the object is the what. So if you can remember that, you'll remember subject and object. So who can access what? Your security posture or protection profile is the sum, the totality of all the controls you implement to counter risk of a loss. So I have a VM out there that hosts part of my class website, you know, it hosts my IRC and a few other things, like my wife's website. There are several things I do to that VM to counter the risk of people breaking into it and stealing the data. Ooh, so fancy data. It's not so much about the data being fancy, but if it went down for any reason, then it wouldn't work. My wife's website would be down, and I would be in trouble. My IRC chat wouldn't work. So all of those things taken together, what have I done? Well, I limit the number of times you can log into SSH in a minute, so people can't get passwords. I back up the data, so that if they do break it, I can just nuke it and start over. Right? I have good passwords, so even with a rate-limited password, you can't guess it. Take those all together, plus anything else I do that I'm not saying. That's my security posture and my protection profile. And those are all controls. Right? So a control is something you do to keep your information in yours and not someone else's. Right? A control is like encrypting data. And one of the keys, and we're going to spend another week talking about this, is really risk. How much risk do you have? How valuable is your data? You know, if you happen to have security cam footage, if you are in possession of security cam footage of the Kardashian mansion, people would probably pay a lot of money for it. Because people are nosy, and celebrity footage tends to be highly valuable, right? The guy who took a cell phone movie of the security camera that caught Ray Rice punching out his girlfriend in the elevator was paid $250,000 for that.
What?
He got fired, but he's like, well.
Worth it.
Security cam data can be very, very valuable. And so how risky is the data that you have? The answer might actually surprise you. But how risky your information is going to depend, should dictate to you how much work you're going to put into implementing controls, so that you don't experience a loss. And that's all the talking I have for you today. Now we are going to hit the lab. Well, why don't we do this? Let's take a 10. Well, you might as well take a 15-minute break, and then what I want you guys to do is partner up. It doesn't necessarily have to be with your groups, but I'm hoping that we can reduce the number of concurrent sessions in NetLab. And then we're going to do the Security Plus lab, lab number 1. It's a cool lab. What you're going to do in that lab is you're going to get a whole network of computers, and you're going to use Wireshark and TCP dump to steal passwords. Yes! Yeah, so get in groups, because I think there's only 30-something pods available, and so do it with a partner. By the way, it helps to do it in a group, because you got to go through the instructions step by step. If you skip a step, you're going to be in a world of hurt. Well, yes, 3 or 4, yeah. Okay, whatever, yeah, you can do it with 3 or 4 people. All right, and I'm going to turn off, I'm going to set the timer, I'm going to turn off the recording, and so if you missed class today, hopefully you can get to it by tonight and get in the lab before midnight. If not, too bad, but the recording is going to go off. I'll probably turn it back on before I say bye. We'll see you later.